All right, hi everyone. I got this webcam, high definition webcam from my office. This Microsoft LiveCam high definition. It's going to cost around $100 or $80 around it. If it's high definition, you can get one out there, but most of you probably have one in your office. So I have this built-in webcam in my laptop. Through that, it is showing me directly like that, and this additional webcam is connected to the laptop, and it is showing the document in here, so becoming perfect document camera. Usually it focuses automatically, so you can go to OBS, for example, and turn off the auto focus. It communicates nicely with the device, and then you have to focus a little bit. Just write down focus, and once you have this one set up, and it's gonna record nicely. So that's that. So I'm going to show you, of course, while I'm writing down and focusing on here, I'm going to be looking down, but whenever I'm explaining, not writing intensively, maybe I can, talk to the audience like that. So here's a little demo. Again, I've been using this double integral all the time because that's my calculus 3 right now. They recently go through this double integral. So this is a symbol of double integral. You write it like this, and often you emphasize that. All right, this is not the 2 integral written down, it's compound symbol, and DA, my textbook writes dx dy, but here I'm going to write it like this. This is supposed to be some sort of volume over there, volume of the solid, and rather than keep writing, you can sketch it here. Suppose this graph of z equals f of xy. Suppose that this is always a positive for a certain region. So our region, this is supposed to be now a three-dimensional view. This is an xy plane there, and over it, for each of the corner, you have the different z values, and the graph will generate, something like this. And I'm going to use this grid line to create a little 3D effect. So you can see this is a graph of z equals f of xy if you have two variable function. And then under it, it generates this solid. So you can look at this whole thing as a solid. This whole notation is supposed to represent the volume of this thing. This is intuitive approach, but often mathematicians want to write down more analytical definition. So its analytical definition goes like this. Just like the Riemann sum, we divide it down there. I think I spoke enough about it. I'm just going to write it down for the sake of completing this thing. P is a partition of xy dividing, and we're going to choose for each of these small subrectangle, we're going to choose a point for which, using that, we're going to determine the height of this little thing inside there, and that's a rectangular box. So for that, we have a volume formula. So I going through 1 through n, this division of x coordinates along the x coordinate, j from 1 through m along the y coordinate, and then this is the selection point for each of this small, subrectangle there. We're going to choose special point inside each of the rectangle, and we usually specify or whatever, the random choice. So that's going to be the height of this part. And then we're going to multiply this side and that side. So product of these three quantity will be the volume of this thing. So you write down this side must be delta xi, that side must be delta yj, something. So allowing this partition method to vary everywhere and choosing any random points inside that box is going to generate this regular box, and then this multiplied to the area of the base, and that's going to be some of the volumes of these many rectangular box. But as we take the limit, if this limit exists, and that is supposed to be the definition of the double integral, and then you're going to go on to next part. So this is a setup, and I experimented. This is wonderful, looks perfect. It is more than I expected. It's working really well. Again, this is OBS. You can go to sources let me show you the entire thing. If you go to full desktop, maybe it's going to show you everything in there. No, it's not. I think it's so I use this OBS to bring in two sources and put them together like this. And there are many different ways to record this one, but let me tell you, OBS, its rendering time is lightning fast. I'm not exaggerating. You just end the recording within 1 second, literally within 1 second. It's going to generate the video. If you have sufficient lighting like this face camera captures really smooth and not, not like a stopping motion or anything like that. So this is wonderful. Problem solved. I'm not sure how much I'm going to use this one, but definitely, I mean, I can do that in my office hours here, and I can turn this Google Meet on, and then you can connect to this document camera, and then you show, go back and forth. This is fantastic. It's a good news. And if you don't have a webcam, I think you deserve to buy this one and then getting it reimbursed. It's out there. You can buy this probably at Best Buy or order it. It'll be here within days. It seems like it's roughly $190 or somewhere around there. High definition is better too for the document camera purpose. Good luck and survive.